nanoHUB.org.
Online simulation, and more for nanotechnology.
Okay, good afternoon, and thank you for joining us for the Data Cleaning with MATLAB workshop. Today, Dr. Kelsey Rodgers is going to go over MATLAB built-in functions, read cell and write cell, to import data and export data to Excel. As a reminder, this is a workshop suited for those who have used MATLAB before, but we will provide links to Dr. Rodgers' other MATLAB videos that do a wonderful job of getting you started. Dr. Kelsey Joy Rodgers is an engineer, engineering educator, and a researcher. She previously worked as an assistant professor and visiting research scholar at Embry-Riddle Aeronautical University. She received her PhD in engineering education from Purdue University and her bachelor's in mechanical engineering from Arizona State University, Polytechnic campus.
Hi, thank you. So as Erin already said, if you are not already on nanoHUB, I recommend getting onto nanoHUB, or if you actually have your own license of MATLAB, I recommend opening up MATLAB so you can follow along. You can test some different things out as we go, and then that way hopefully you'll have more questions if you come across things that you're struggling with. So if you're on nanoHUB, you can just search for MATLAB, use the link provided, and go ahead and launch the tool and use MATLAB from here. I will be using MATLAB from my computer. So here I already have MATLAB open. Also, to get started, I downloaded a bunch of different data online. If you don't already have some Excel files with a bunch of different data that you can use for this workshop to go through and try to practice and see how to read that file in and do some initial analysis, there are a lot of places you can go online. NOAA, they have tons of weather data. You can find historical data. They have sites that have sample Excel files. There's a lot of different options for just blank sample data. So a lot of the data that I work with personally is healthcare data. So I will not be using any of that since that has a lot of personal information that I can't share. So I'm using a bunch of sample data that I have found online, and that's what we'll be using in this workshop. So as Erin already stated, one of the first built-in functions in MATLAB that we're going to get started with is read cell. So before we get started on anything, we need to, again, have that Excel file, have MATLAB open, and then the first thing we need to do is we need to upload that data into MATLAB. So MATLAB interfaces with Excel very well. It has this read cell function. Yes, there is also a XLS read function, but I recommend using the read cell function. This is a more updated version of the built-in function. So with read cell, there's a lot of different ways of approaching it, using it, how you want to first read that file in. So first I'm going to show one of the more simpler versions. So we can just read in any Excel file. So I can come over here and look at my current folder and see a bunch of different Excel file options that I have here. So let's go ahead and start with, we'll do the Lafayette weather data. So I'm just going to go ahead and copy the name here, and then I'm going to paste it over here. The reason I do that is because I don't want to accidentally typo the name of my file and cause errors and not be sure why I'm getting errors. Also, you'll notice when I copy the name of the file, it did not copy the file extension. I do want to always add that in. So again, I've already written my first line of code. This is one way of approaching this. So I'm going to go ahead and run my code. It's always a good idea to, whatever file, whenever you're writing any code, run it as much as you can. So I'm running it. This is a very large file, so you can see here it's still running. If you don't see the little arrows, just as a reminder, the prompt here, then you know that your code is working. So I won't use this file the whole time since clearly this is a much larger file. There we go. And I'm going to move this. One way that you know this worked is it shows up here in your workspace. I like having my workspace pinned so I can always see what's going on, what's my current variables, what do I have uploaded, and you will see here there are 64,000 rows of data and 50 columns of data in this Excel file. So we can go ahead and just look at that one too. Right here, this is that Excel file. Now, if I'm going to go through and try to analyze all of this data, that's a lot of data to look at. way too much for me to manually look at, obviously, and even a little bit much to try to analyze all of it in Excel. So I personally would prefer to use MATLAB, which I have found MATLAB's really good for cleaning data, analyzing data, and trying to understand what's happening. If I open up my variable here, I can double click on it and I can look at the variable. Again, it's going to take a while to load, but hopefully it'll at least load the first couple for me. So here I can see the exact kind of same format as what I'm seeing in the Excel file. So one of the first functions we're going to get into is addressing these is missing data points. So a lot of times you'll have an incomplete Excel file. Your Excel file is going to have missing data. Sometimes it might have missing data that also has data in there. So there's a lot of missing. But so see here we have an example of this column has both data and missing data. There's all sorts of different ideas like this. So again, this is probably one of the most common things I see people dealing with is removing missing data from an Excel file. So first steps, reading the Excel file again. Now, since I have already read that Excel file in, I'm not going to run this code right now because I don't want to clear it back out. Actually, I'll just comment this out for a second. Another way you can read an Excel file in is using this UI get file. So this is an additional function. So read cell, one built-in function in MATLAB, very useful to use. UI get file, another one. The benefits of using this approach is if you notice here it says path. This is going to look at where the directory is, where the file is stored. This one you'll notice does not say anything about where the file is stored. If I'm taking this approach, I can only look at Excel files that are stored in the same file as my present folder. So this Excel file is in the same folder as where my code is. So I don't have to say what the path is, what's the directory. So that what I mean by that is what's this link, telling it where to go. Using the UI get file approach, I can actually go in and then pick a folder or pick a file anywhere. So right now I could pick one of these. We'll just do this one. And I have it semicolon suppressed. I just overwrote my data because I have different data here. But if I look at path, this says my current directory. But I can also work with data that's in different folders. So I can go to any other folder I have. So we have another workshop we did recently. So let's go to that one. And I have an Excel file over here. So I'm just going to go ahead and say that one. And you'll notice the directory has changed. So again, UI get file is very useful if you don't want to store your code in the same place where you have your data file. For the rest of this workshop, I will probably just stick with this version just because it's easy for me to run it multiple times, do any error checking, troubleshooting, and not have to reselect the same file every single time. So when I'm in the process of developing a code and it's for one particular data file, I normally use this approach. Once I'm completed with this, I normally change it to this approach. That way I can then run the exact same program for any set of data that has the same format without having to update the file name. So one thing I will say is I do already have this built-in function. I use this built-in function a lot. This is a function that goes through and it looks for anywhere that has missing data and it replaces it with just empty data. So I'm going to go ahead and copy this same content. I could call this function that I've written, but that way you can still see what's happening. I will go ahead and put it here. So one option is I can go in and just change all my missing data to empty data. I will just show you this in the command window. That way I don't have to wait for it to rerun and upload the same data file. And it is going to take a little while because, again, this is a very large file. There we go. So now if I look at my data file, remember before it said missing all over the place? Well, now I see this null, empty, all of this empty data. This is an option to first step cleanup. You don't need to clean your data by replacing missing with empty, but it can be beneficial. One of the benefits that I know is eventually if I want to write this data, however I analyze it, change it, if I want to write it back into an Excel file, I can't have missing data. So any missing data, it cannot write into an Excel file. And just to prove that to you and show you a little bit, I will go ahead and write that here. So if I just run my code, after it reads this file in, it's going to give me an error. It's just, there we go. So see, this is exactly what I was just saying. So any missing information cannot be written into an Excel file. So again, sometimes one of the first things I like to do is just remove the missing information. Depending on the context of the Excel file, sometimes I'll actually go through and look at all of the columns that have all missing data, and I might just delete that entire column out to begin with. All right, so let's go ahead and switch over to a different Excel file, just because again, that's an Excel file with a lot of data, a lot longer. And we can go ahead and start with this data first. A very useful feature in MATLAB, if you don't know it, is running sections of code. So this is another way of just testing parts. So I'm just going to run this first section of code. I did that by doing 2% signs create sections, and then I just said run section. So it's already done. So again, this is a much smaller data file. So in this data set, I don't have as much missing data, but I do have some missing data. So again, this is a case where I could do the same thing, go through, look for any missing data, replace it with an empty thing. But instead, this time I'm going to go through and actually say, okay, if there's missing data for this particular data, I know that this is actually not very useful to me. I don't want this missing data. So I want to remove the whole row that has a missing sale and a missing profit. So we'll go ahead and go through that together. I'm going to first show you the most common error that I see when people are trying to clean that data out, and then I will show you the correct way to do it. So again, it's important to understand the context, because I don't want to be looking for missing data and say, okay, if there's anywhere missing data, then just delete that whole column, because then I would lose all of the data that I really want to analyze. So in this place, I know I'm okay with deleting the whole row. I don't want to be deleting the whole column. So as for getting started, I'm going to have a similar approach here. I want to go through this data in a for loop. I don't want to be going through rows and columns separately. I'm just going to be starting out with going through all of my rows. So again, I like having this up sometimes for reference. So then I'm looking at it, I'm thinking, okay, the first row is my title. I don't want to be analyzing data. I don't want to be doing anything with my title. This one's convenient because there's only one row for the title. Sometimes there's 3, 4, 5, 6, depending on what your data looks like. One of the first things I like to do here as well is I like to just grab my title, store it somewhere else, and leave it alone. So I'm saying all rows, first column, just take all of that information, store it in title. That's just a variable name I like, because then I know what it is. And then actually go through and delete it. So using diminution, I'm going to delete that first row. Now, once I delete that first row, I'm going to go ahead and do that just real quick in the command window so you can see that it's done. And I will reopen data. Oops. Sorry, I deleted my whole first column. Row, comma, column. Common error. There we go. Let's run that again. Another good reason to run your data frequently. So there we go. Now I have my whole first title missing. It's deleted out exactly as I wanted to. I stored that information in title, so I still have it elsewhere. Now I know I want to be looking in the fourth row and the fourth column and the sixth column to be seeing, okay, if it's missing information in the fourth column and the sixth column, I want to delete that out. So one important thing to be aware of is when we are working with reading an Excel file in, the type of data we're working with is a cell array. So if I were to just extract this information, I'm going to extract the whole cell. So it's like I have a packaged box and I haven't extracted anything inside of it. So here, instead of parentheses, I'm going to use braces. So that says open the box. I want the information out of the cell, not just the cell itself. And the reason that's so critical is if we look at row 11 is the place where I'm going to be analyzing this data. If I were to take, 11, 4. All right, so if I were to take this whole box and I'm looking at it, it's missing data. But if I were to say, okay, is this temporary answer missing? It's going to tell me that's an error because I can't use is missing on a cell. But if I were to do the same exact thing with braces instead, now again, you see that I don't have it inside of a cell array. It's actually missing data like this. Now if I check, it comes up true because it is missing. This is a place where there's missing data. So now I want to keep that same idea in mind here. So as I'm extracting data out of that cell, I'm checking to see if it's missing. And if it is, then I want to remove it. So I would want to remove all the data in that row and just say delete it, the same way we use diminution up here. Now, some of you might be familiar with having this kind of approach, and if you are, hopefully you already see the error before I run this. If not, that's okay. I'm going to go ahead and run it, and then we'll look at the error together. Again, this is a really common error I see when people try to clean their data. So the error I'm getting is that all of a sudden I'm looking at row 1003 I'm looking at row 1004 and my data only goes to row 1003. So something went wrong. And when I go to investigate further, I'm seeing that I actually still have missing data as well. So it's not removing some of the data. This is a very common problem I see when people start cleaning Excel files. I can't delete so if I go here and I delete row 11, so I'm saying, okay, delete that whole row, and then I say, okay, now go look at row 12. Well, guess what? Previous row 12 is now row 11, so I'm skipping that row. So very easy solution, instead of looking at row 1 first and working top down, I go the opposite direction. So I want to start at the very bottom of my Excel file, and I want to go counting backwards by 1 until I get to the first row. So now if I run this same thing again, it works. I cleaned all my data and I no longer see any missing values for this fourth row. So again, or this fourth column, I apologize, keep missing rows and columns today. So again, the reason this is important is I can't analyze this data. I can't analyze this numeric data until I remove those missing values. Depending on our context, I might want to keep track of those. I might not care. If I did want to keep track of those, I could simply do a count of my missing ones. So I would start out my count with 0 because to begin with, I don't have anything missing. And then every time I remove one, I can say, okay, my count is whatever my count is previously, plus one more. And now I would simply be able to know how many times, how many different values were removed. So there was 8 rows, 8 sale items removed because they were not completed. They had missing values. All right, and as I said, again, this is important for analyzing the data. So I'm just going to show you without removing that data. So run section. So if I look here at my data, let's say I want to analyze all these numbers. One easy way to grab them all, I can just say data, all rows, 4th column. That selects all that data. Now, if I'm going to do any type of analysis with those numbers, I need to convert my data. So I'm going to convert it from a cell array to a matrix using this cell to map built-in function. Now it gives me this error. The reason I'm getting the error is because I have missing data. So again, if we go through and we actually run the whole program that we have so far, and we extract that information out here, which let me go back to my original. So those are my sales and my profits. So I'm looking at sales in column 4. And since I'm extracting sales already, I might as well do profits as well because it's basically the same thing, just changing the column. And it is just going to print out a ton of information. So let's just start by throwing a summation on here just to have a final number. So you can at least see that cell to mat will work once I remove that missing data. So then it has final profits, final sales here. And again, this is context is important. Whatever reason you have for analyzing the data, whatever you're doing with all of this, then there's probably a lot of different approaches you're going to take here. But then at least with the first step, we can, again, keep in mind of cleaning up our data, getting rid of missing information. All of the Excel files that I was finding that had sample data, I will say, look fairly clean and pretty. Other than the weather data, again, had tons of missing information. But a lot of times if you're working with data you maybe downloaded from a survey or different data online, a lot of times there's extra columns involved with data that you don't need, you don't want. That can just be simply going through and deleting them out. You can manually say which columns you want to delete, or you can look for certain information and say, okay, if that information is there, delete this column, delete this row. It all has a fairly similar approach to this idea of doing a for loop, going through the data, and getting rid of whatever it is you're looking for. So just if statement inside of a for loop. Again, is missing is a very useful function to make sure to be aware of when cleaning data. Another one that I did not have to use in this case, but I do use a lot is empty. So that's looking for those nulls. So when I switched all the missing data to those empty brackets, if I wanted to look for that data in particular, I could say is empty. All right, so getting into analyzing the data, let's look at this particular data again. I'm going to zoom in a little bit. So again, this is just sample data that I was able to find online. They have some different orders, when these orders were taking place, and how much the sales were and what was their profit or loss on the particular sale. So, and I don't know if these are, I believe these are fake customer names as well. And then different product categories. So one of the first things that comes to mind when looking at this is thinking, okay, maybe I want to do some type of sort of my data just based on different categories or different customers. If I want to look at small business, corporate, home office, or maybe I want to look at office supplies, furniture, technology. So if I want to get an idea of like, am I making the most profit in which category of product or which person, customer that I'm targeting, or which particular customer, maybe that's probably a little more detailed than where to go. Again, it all depends on your goals. So let's go ahead and start with product category. just because this is one of the types, and I imagine this one only has 3 options, and this one I don't know how many options there will be, so we'll find out. So looking at my data, that is in my 10th column, so I want to start out by looking at what are those options in that 10th column. Now I can manually go through and try to figure out what my options are. I could come over here to Excel and see what my different options are. Or I can use a function in MATLAB that can figure that out for me. Now, ideally, anytime I can use a function to find information rather than manually putting something in, I will take that approach. Because if I manually say the 3 options that are showing up on this particular data set, I'm limiting myself to only working with this data set. If I say, okay, I want to keep in mind maybe on future polls of this same data, same format, I might have different product categories. So I want to leave it generic to work for anything. So if you don't already know about the unique function, that's one of my favorite functions for analyzing different data. So I'm just going to show you quickly here first. So if I say all rows in that, again, 10th column is my input argument, then it tells me, okay, these are the 3 different types of product categories that are showing up in that 10th column. And I can just as easily quickly see, okay, where, so I actually do have more different customers, like types of customers segments than I do product categories, which is kind of a surprise to me, but it's something I can quickly see in my data with the unique function. And I imagine the list of customers is going to be a lot. So yes, I can see that is a lot. It says right here in my workspace, 430 different customers. I definitely don't want to analyze this particular data based on that. That could be something that you would want to do. Again, you have that same option using the unique just like I did here. Alrighty. So I'm going to go ahead and parse out my data based on my different product categories. So again, it's going to pull these 3, and I'm just going to group my data together based on these 3 different categories. There is both size and length functions that you can use that do pretty much the same thing. I prefer sticking to the size function typically, just out of a good habit. The big difference is size is going to pull both the number of rows and the number of columns. I'm specifically telling it to pull the number of rows. Length is always going to look for which one's bigger. So sometimes I have data sets like this one where I have 10 columns. And as long as I have more than 10 rows, it's always going to look at rows. But in the case where I have like 3 rows of data and 10 columns, it would tell me the larger size of 10. So again, I prefer to make sure that I am specific about saying I want to know how many rows or I want to know how many columns depending on what my goal is. Now my goal here is again to group all my data together based on my different product categories. So I have, as I already know, 3 different product categories, but I'm not going to say go through my list 3 times because again, that's an example of hard coding. And anytime you hard code, you can't reuse your program for a lot of different scenarios. So I avoid that as best I can. So I'm going to look at each of these individually one at a time. So this for loop has a goal of slicing them out one at a time. So just to show you this without having to rerun the whole program. So you'll see one at a time it's slicing out each of those main categories. And I can just slice all of that from my data. So So I want to compare all of my data from that 10th column to the current product that's being selected. And I'm just going to store it in. And then say, okay, all columns of that data. So again, just an example, this is going to grab the most recent one, all the technology ones, because that's my current variable for product category. So if we see here in Analyze, you'll see it's sliced out all the data that has the product category technology. And now I could go further and I could say, okay, now I also want to segment my data out based on if it's corporate, home, or individual, or any of those different categories, or I can slice it out based on something else as well. But I at least have technology sliced out. I can do further analysis on each of these. So a simple thing might be a count of how many were negative, how many were positive, what's my minimum, what's my maximum. So like my greatest loss, my greatest gain, and what's the average. So that could be some type of simple analysis that I could do here. So after I do the analysis, I say analyze, I can sum them up. I can, like I said, I can do minimum, maximum. Those are all functions that are built in. There's a ton of different options, ton of different functions. And again, I prefer anytime I can to use copy and paste because then I'm avoiding the user error of typing something incorrectly. And I'm not going to bother doing a bunch of fprintfs or storing the data in a bunch of places. I'm just going to do some simple demonstrations here. So min and scope. And yes, I've had plenty of times where I'm copying and pasting and I'm mischanging something, which is frustrating, but does definitely happen. So let's store some of our analysis here. So every time I run through my list, I might want to keep track of, let's say, a collection of different information, such as what was the category, and what was the total sales, total profits, and again, minimum, realistically, I'd probably want to group this differently, but since it's just for an example, I'm not going to be too worried about what's my order of how I'm grouping this data in here. I just want to show you some simple approach to something I can do when analyzing all this data. So let's just start here with running this. So now we see here I have this collection of information that built through running all of this data. So it's pulling furniture, office supplies, technologies, and the total sum of sales, profits, the interesting. Oh. So quickly I can see all my numbers are the same, which is a red flag. So again, that copy and paste got me into a little bit of trouble. I'm analyzing the whole data and not just my subset of data that I have here. So I'm just going to swap those out real quick. It's always good to look at your data, again, be familiar with it, be aware of like what might be a red flag. If there's a red flag, it's probably a user error. You probably don't have data that's going to happen in. So now we see differences. So I know that, okay, I did analyze the correct data. Again, not sure what your analysis goals would be, but again, similar approach. Main thing that it's important, I know that I have options of unique. Unique is, again, one of the most helpful functions I feel like for analyzing data anytime I'm doing categorical analysis. So I'm looking at different categories of my data and then going back to like is missing, is empty, critical for actually looking at removing cleaning data. All right, so since we have some initial analysis, as simple as it may be, one of the things that we would like to do a lot of times is actually write that data somewhere. So I can say whatever my data is that I want to write into an Excel file, I'm going to go ahead and suppress all this. That way when we run it again, it won't pop up. Okay, so write this into an Excel file, and I have to name the Excel file. So just like when we are reading an Excel file in, I have options for writing the Excel file. I can do something simple where it's just saying, typing the data here, or sorry, typing the file name here and telling it where to print it. And so if you noticed, it popped up over here. So I have a new Excel file, and now I have that data that we just analyzed is now in a new Excel file. So again, I'm more worried and concerned about the process here and making sure we're all familiar with different ways of going through that process of read an Excel file in, clean it, analyze it, output that data to another Excel file through Brightcell. So one of the things that I will say I have done far too often and should know better is sometimes I will get a little lazy and I'll just write my file name right here and call it done. And then I will go ahead and rerun my same program for a different Excel file that has, again, that same type of data, but it's for a different pull. So let's say I'm pulling data for 2021, and I want to know, okay, what were my sales, profit margins, all of that for 2021, and now I'm pulling data for 2022, and I'm running it for these two different files. It's going to work for both if it has the same format. But here's my problem. It's also going to print to the same Excel file every time. So all it's going to do is overwrite my existing Excel file. So I recommend not just putting in a simple export data like same file name, because it can be frustrating when you overwrite your own reports and you want to go back and look at old reports. So a lot of times I'll just put file name here. And then I will create a file name depending on what my context is. And if you're not familiar with string functions, I do have a whole series on string functions. You can look into those more, but sprintf is a very useful string function. It is very similar to fprintf. If you haven't used fprintf, then definitely go look at videos for all of those. But sprintf will create a string based on different text and information. So since I have this format here, I'm going to change this and go back to what I would normally use, which is this one. Since I'm calling this the file name here, I will actually call this file name out. Doesn't really matter, but one of the things I like to use sometimes is the input file name. So I like to use that information in my output file name. A lot of times when you download a bulk amount of data, sometimes there will be like a date or something, some type of information in your file names. If you have that, that can be very useful. If you don't, I would recommend trying to look at, well, what's there, what's useful in that file name, if anything. For instance, if I'm downloading data reports for different regions of a state, sometimes it'll have a region information, like a region name at the very end. And a lot of times I can look for, okay, it's after the underscore, everything after that's going to be the region name, so I can grab that out of the original name. In this case, my file name was, where did it go? My file name is orders with nulls, so not very informative. In that case, I can still just leave that, but I'm not going to use that file name. I changed my mind. I will use the date though. So I want to say, let's say, sales analysis, and then I would want the date there, and I would say .xlsx. So again, it's important you keep that file extension. If it's Excel, and you're not using XLSX, then just put XLS. You can do a CSV file, but it's just important to include that file extension. If you don't, it will default to a text file a lot of times, and most of the time you don't want to be analyzing your data or reviewing your report in a text file. If you do, then good news for you, you don't have to worry about it, but I would still put .txt anyway too. So file extensions, always a good idea. All right. Just checking something real fast. All right, so for today, I'm going to put today's date based on what we just did in the command window. And I do need it to be a string. I think I can also use char. Yes. I personally prefer char over strings. I don't like using strings too often in MATLAB, personal preference. They came out fairly recently. All right, so file name out, and again, that's going to be printed there. So instead of seeing export, I will see my new file name. So if we look at sales analysis right here, and then we see the date here. Now, if I run the same report multiple times in the same day, obviously it's still going to overwrite it. But let's say I go to rerun this in a couple days. The good news is at least I know I'm not going to overwrite reports from previous days. So I will be able to have historical runs of my program. So again, just a little habit that I like to help with is doing something that's going to create some unique print on your run. You could put a version on here, but you're going to have to manually put in the version, or you're going to have to keep track of that elsewhere and then be pulling that version and updating it every time. So that covers all of the main categories. I don't know if anyone has any questions at this point or anything, maybe like specific problems you've ran into when analyzing or cleaning an Excel file, writing an Excel file. I guess if you have experience with XLS write, which is again another function just like write cell, but specifically for Excel files, I will say that is an older version of the write cell and read cell function. And one of the really cool things about all of this is I am currently on a Mac. So Mac used to not be able to interface well with Excel in MATLAB, and XLS Write actually will not work on my Mac. So if I were to, say, do the same thing, XLS Write, the input arguments are the opposite direction. It tells you I can't use XLS Write because I can't write Excel files on a Mac. So again, write cell is the newer version of this function. I recommend using this. So even if you're used to XLS Write or XLS Read, I really do think there's a lot of benefits in switching over to the newer built-in functions. If you're Googling it and you get recommended to do other functions, again, I really recommend the version of the read cell, write cell.
If you want to remove a row between data sets or a set of rows, can it be done without manually finding the rows? Can we say check the input in the first column and use that to have it coded?
Yes. I think what you're asking is, like this one, I'm not manually removing the rows. Like I'm telling the code to go through and like remove rows one at a time. So I'm looking at column 4 based on like what I'm seeing. And I'm wondering if that's the example of what you're looking for. And as far as the indices part, like, well, let me answer that question, this one first. So is this what you're looking for? because again, this is removing a set of rows without me, I'm not reading in the Excel file and saying, okay, I know I need row 10, 11, 12, 13 to be removed and then manually removing them. I'm saying, okay, based on a specific criteria, look for that criteria. If that criteria is true, delete the row. And yes, instead of like looking at the fourth column here, I could be looking at the first column. So what is my first column anyway? Unit price. Or no, sorry. Order ID. I don't know why I'd be removing based on order ID, but I could. I mean, if that's the particular one. Again, I picked the fourth column because this had missing cells. And yeah. So if you have a follow-up question related to that, let me know, and I'll follow up on that again. And as far as vector indices, what I think you're referring to is something similar to what I did here. So instead of going through these rows one at a time, I know I wrote it all out on one line of code, so I'll just write this out step by step, kind of. So here, I'm looking for a particular product category. So let me first just do the product category. So my particular product category right now is technology. So rather than going through and looking at every single row one at a time and saying, is this technology? Is this technology? Is this technology? You know, and like looking at every single one of those data points, I'm saying, okay, where is technology? So I'm using the string compare function, and the string compare function will then look for technology and say true or false. Oops, I'm missing a parenthesis, sorry. Oh yeah, because I have grabbed another part of it. Okay, so then I'm doing a string compare. I'm going to scroll up fast. There we go. So I'm doing this string compare, and it's looking at all 999 rows of this data set, and it's saying, okay, based on that 10th column, is it technology, yes or no? So if we look on the first one, 0, 0, 0, 0, the first one shows up on the 5th row. False, 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 1, 2, false, 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 true. So this one is technology on my 5th row is where I have my first technology. So it's saying true. So again, this is a place where instead of having to look at it one by one, for this particular thing, I can use the function string compare. And in that case, then I would just slice all of the data that is true. So that's written all in one line. So then now you see I have all of the technology data sliced out. So all of these are only technology. I just happen to do it also in a for loop. Okay. I kind of snuck it in there because I didn't say it specifically, so good. But yeah, again, it's all on context. So it depends, like, what's your data that you're using, how you're using it, and all of that. I can share both the data and the file because, again, the data is just data that I found online, and it is open access data. So I did not use any data that was personal to me for the purpose of this being recorded, and I can share it.
Let me see. Is there a way to combine similar data, say a data category with small typos or differences, into a single category? For example, if capital CA, capital C lowercase a, Calif, and California are all referring to the same region, and you would like it to all be called CA, or if a person's names are sometimes with a middle initial and sometimes not.
So yes, is the quick answer. The long answer is, again, it's going to depend on the context and how complicated it can be. Yes, it's going to be possible. It all depends on, again, how complicated. Very simple for small things. String compare right here. I have string compare with this like extra little I on the end. So there are two string compare functions. This particular string compare function has an I on it because it is not case sensitive. So just using this instead of the string compare with an I, or sorry, without the I, makes it so it doesn't matter what casing. So that would address any of like the capital C and lowercase c. So that's an easy difference. Sometimes you start getting things like where you have, again, someone's name and then they have the middle initial sometimes and don't have it sometimes. That gets a little bit more complicated, but you always have options. So I'm just going to create an example real quick. So let's say I know that these two people are the same person and I want them to show up as the same person. Let me add another one on here. So there we go. Well, let's do the case one real quick. So first let me clear this and rewrite that. So string compare. Sorry, sometimes I have the bad habit of just letting it default to ants, but really I should store it somewhere so I can keep using the same variable. String compare. So if I'm looking at this and I'm looking for Andy Smith, first, if I'm just doing string compare, it's only going to see that first one because, again, it's case sensitive. String compare I is now going to see the first one and the last one, but the problem is it's still not going to see that second one. So another option that I have, I don't think I can lower the whole thing. I think I have to do it one at a time. Oh, I can. Oh, perfect. So I just wanted to check and make sure. There are two functions that I like to use for things like this. There's lower and there's upper. So if I say upper, it makes everything capitalized. So then I don't have to worry about being case sensitive with my data. If I say lower, again, it makes everything lowercase. So I don't have to be worried about being case sensitive again. Instead of string compare, there's another function called contains. So if I wanted to split this name apart and look specifically for Andy and Smith as two unique names, I could say, okay, let me test equal lower. So I'm going to make everything lowercase because contains is case sensitive and I don't want to have to deal with that. So if I'm looking for Andy, it's telling me everyone contains Andy. Now, I don't want to just say Andy in general because anything that has Andy, I might have multiple people named Andy with different last names. And Smith is a very common last name, so I probably don't want to look just for Smith. But if I were to say, okay, if it contains both Andy and Smith, then I'm pretty confident that it is Andy Smith. So in this case, I could grab Andy Smith and Andy J. Smith. And then that way I can make sure that I group those together. So that's going to add some complication of making sure that you understand your data. One way I might go about collecting that information is, so in this case, I can't, if I do unique on test, it's going to show up as two different people. So there's going to have to be some additional coding to go through and look for these similarities, and it might require some like manual looking at it, or if you want to get complicated enough, you could also look for like is space. If I look at, I'm going to look at the first, or like first name on this list. So if I do is space, it tells me where my space is showing up. One thing I can tell from this is I know I only have one space and I know where it is. When I look at the second one, I know that I have two spaces and then I know this is where they are. So one thing I could do is I could say extract all of the information before the first space and after the last space. And that way, so in this case, there's only one space. So I'm extracting all of this and all of this. And then in the next one, I would be extracting all of this, which would be the Andy part, and then all of the last part, which would be Smith. And so I could rewrite all of my names going through that kind of approach. So going in one row at a time, looking for spaces. If there's more than one space, I re-modify it to remove any middle part of the name. That's one approach. Or again, doing the contains just to see if for similarities. So yes, it's possible. It just depends on the context. It's going to add a little bit more complexity. And again, it's going to be kind of going back and forth, testing a little bit and seeing what works for you. One thing I'm going to say is efficiency. So if you're going through everything one line at a time, then it's going to take a lot longer. When I do like that example where we had the string compare and I extracted all the data in like groups, that's a lot more efficient. So it's going to take less time in MATLAB. So when you're going through and you actually get it working, after you get it working, you might want to reanalyze your whole thing and say, okay, how well is this working? And one thing to do that is tick and talk. Those are two functions that I like to use a lot to check my efficiency. So what I just said took 5.5 seconds basically. So I can put tick at the beginning of my code. So we'll go ahead and I'll show you here. So I can put tick here, and then I can put talk all the way down here, and it tells me how long it takes for my code to run, 0.9 seconds. If it's under a couple seconds, I normally don't feel the need to further analyze it. But I have had plenty of times where a chunk of my code, like let's say, for instance, one of my for loops seems to be taking longer than I think it should, then sometimes I'll throw tick and talk around it. And if I know that that's the particular part that's taking a long time, then I'm like, okay, what can I do to make this part more efficient? But again, the first part is just, can I actually make what I'm doing work? So you'll see here, this first for loop is actually takes longer than this next for loop. So this next for loop does a lot more slicing, but I use that referencing, like the referencing different indices approach. And that's a lot faster than, again, doing that manually, going through and looking at every single data point, opening every cell, looking at it, and then making changes. But again, still efficient enough, I wouldn't really be concerned about making it more efficient. When you start doing the changing the names, yeah, you might want to track it. And thank you.
With XLS read, the numeric data, missing data is replaced by NaN. So if I want to search something in this data matrix, we do not need a for function for the whole data matrix. Whereas for the read cell function, writes everything in a cell. And I feel that extracting the data from read cell into a normal numeric matrix using a for function is time consuming. Do you have any method to convert the whole read matrix data into a data which is similar to Excel read?
I don't have much experience with read matrix. So let's start with, I'm just going to grab this and throw it in here. All right, NaN. So when I'm looking for NaN, I'm using isNaN. I think, okay, and so then it's automatically just putting in NaN. One thing I could do, so you're wanting to, if I wanted to throw this data and I wanted it to be with my other data, I'm noticing it automatically removed my first row. So let me check this real quick. I'm pretty sure the only difference in data size is 1. Yep, so it just removed that first header, assuming it was the header. Okay, again, I haven't done this before, so bear with me. We're going to try it just out of curiosity, and I don't know if this is going to answer your question exactly. So let's just throw in that. Data 2 equals this. And then if I wanted to have this approach of doing read matrix, I'm guessing the reason I'm doing that is for 1 through 4, 6. Okay. All my rows. So 1 through 4 is all numbers. 6 through 7. And then the rest is all string data. Again, not sure if I can do this, but we can try it just out of curiosity. I always like trying new things, seeing what happens. Let's try it. Cell to double. Oh, okay, wait, let's go. So I'm just going to put all those numbers in a cell array. Yeah, so I could do that if I wanted to. So if I look at my new data, I've replaced all of the numeric rows, or sorry, numeric columns. I am really off on my rows and columns today. Numeric columns with the numeric columns from read matrix. So as long as those columns are always going to be the same columns, because again, this right here is an example of hard coding. I looked at it and I said, okay, these columns are numeric, so I'm going to say go ahead and replace all the columns in the original data I'm reading from the Excel file with the data I'm reading from the read matrix function. So yes, that's an option. You can absolutely do that, and that way you don't have to clean the numbers. I'm going to put this like in a little comment. That way I can leave it in the file, but it won't change anything as of now. So yeah, that did work. Then you would just have to be aware of like, okay, again, these are NaN, so they're staying in here. So remember when I went through, I deleted them. And if I were to run this, it would be keeping NaN. And one of the other things that I want to be aware of is if I'm doing this based on data, then yeah, when it's an NaN, I would assume it's just seeing it as a 0, kind of, or like not applicable, so it skips it. So it's not going to affect the max, min, or any of that. So hopefully that answers your question. Again, I've never used read matrix ever, so cool to see how it works. I typically am always doing things that have a lot of string data, so I wouldn't really want to have to go in and like do all that. It's just easier for me to modify the numbers in the Excel file data. But this is a cool approach, another way you could do it, so I like that idea. Some with a NaN, it did screw it up, just so you all know. Okay. I'm not if whoever wrote is it possible to go through the rows one at a time, find key term, then take all the values and write it into a column until reaching null? If you have further follow-up on that, like I could use a little bit more detail. So this is an example of I am going through one at a time. This is an example of like I'm just going through in bulk because I'm making it easier so it's more efficient. But I can go through one at a time and look, instead of saying like this condition where I'm deleting stuff out, I can look for a specific key term or key idea and then store that value for a specific reason. I could, even if I wanted to, in here. So here I have analyze and I'm grouping that data out, but I'm not storing that grouped data out anywhere. If I wanted to store data, so I'm going to go through and say, based on X, I'm going to store analyze every time. I'm going to tell you in a second, like what I'm doing, function data, because I commented this out. There we go. I might have commented something else out. No, we're good. So this is what my analyzed data looks like. Again, this is just showing the most recent one with technology. I don't have access to the other two in the previous way I wrote it, but store data. Now you'll see I have 3 cells in here. And if I open one of these cells, this is a cell array within a cell. And this is all of the information for furniture. And then if I go here, this is all the information for office supplies. So I've now stored all that data in a cell. So I have a cell array within a cell, and you can do that too. But just keep in mind when you're extracting it, you have to open the cell, and then if I want specific data, I have to open that subcell again. All right, and thank you. Right. Okay, and then to go to the pixel data. All right, let's just take kind of prefer a yeah, let's do that one. Save image. All right, so I'm going to open up a different file for this one because this is a whole kind of different direction. I'm going to look at that one too. I'm not sure with the image one what your goals are, but I think I just saved it in here. There it is. Again, I like to copy paste when I can so I don't have to hit something wrong. So I'm not sure what your goal is necessarily, but when I have a picture, I do have this 3 by however many rows and columns by 3 dimensions. And so it's the RGB color profile. So like R is going to be pick all rows, all columns, red equals. And the first layer, I believe, is the red one. Yeah, I think G, same thing, but second. And I don't know if that's what you're asking, but I can analyze that data and do a whole different thing with analyzing image data. Different purposes, different goals. So now you see this stored here, and it is a different data type. So you see it's the UINT8, but that's a whole different category. But if you do have a follow-up question on that, I can try to answer it. But there's a lot you can do with pictures too. I do want to get to this other question. If you do have a follow-up question, again, feel free to ask it. The key term is in the same column. Okay, I think I understand the question that's being asked about the key term in the same column. And then, so I'm thinking it's something like an example where, like sometimes, and I've had this plenty of times, especially with billing, I will say that's the place I see it most common is when I'm downloading like billing type data. Like I'll have a client's name or something like that, and it'll be, here's one whole row with their information. So one, or it might be like a customer, and then this one's client too, and like these are different names. And then this is all the data for this one person. I think that might be what you're talking about. And if that's the case, I will just say, to me, this is like one of the most annoying things I come across in analyzing data. And I do see this a decent amount. A lot of times these are the same, or yeah, that is what you're talking about. Okay. Yeah, I find this to be one of the most annoying things. But most of the times this is the same. It's either going to be missing, it's going to be empty, or there's a title here. So what I look for is I will go through and I will find all of my rows that have that to be the same. Okay, so here I'm just going to make this a sample file. And I want to make sure you see that I have different spacing here. Like I don't have the same number of rows, columns, anything like that. And then let's go from here to the end. I'm just going to get rid of a ton of this data so it's a little bit shorter. And I'm going to save this. Okay, so let's go in a new one. Again, copy paste, always a friend. And yes, I normally always use the same data name, but that just please keep in mind that's just the variable name that I like to use. Use whatever one you want to use. I'm going to go ahead and run this. So it's going to close everything else out. So here again, sweet. This is that random title that happened to be there to begin with. So I'm just going to delete that and ignore it because I don't really want to get into having to look for that and look for the other stuff. And we just want to get rid of that whole first row. Don't care about it. Delete it out. What I really care about going through the example of is like I have client 1 here, client 2 here. In this case, I have these same titles here. So I can say whichever column I want to go off of. I'm going to just pick the second column because it's the first one that has that same piece of information there. I could use a for loop. I don't need to use a for loop here yet. So this is a time where I like to not use the for loop if I can avoid it. I am going to check something really quick just to make sure. String compare is normally pretty okay with numeric stuff. Yes, okay. I'm going to use string find instead. And I'm going to show you the example. So I did string compare, it gives me trues and falses. If I do string find, nope, it's not going to let me do it because I have to have it. Okay. So this is a logical. It will tell me where all of them are. Okay, and then what I want from here is I want to know what rows those are happening on. So one of the easiest things to do for that is going to be, I like using the find function, so that'll tell me the rows. So when that's equal to 1, that's where there's that title row is happening. So these are where my title rows are occurring. So my, like in this case, I put client name. I didn't really put a name there for you, sorry, but client name is going to be all of my data from those rows in the first column. So this will grab all my client names. So I have client 1, 2, 3, 4. There's a lot of ways you can approach this from this point on. One of the ways that I like to approach it that I think is it just makes it easier for all the rest of my analysis is I actually just like to take those client names and throw them in their own column. So I like to create another column on the very end that has those client names and then just delete this row out. And then that way I can treat all my data the same. So I can do that by going through my data. I've written this a few times and I have to think about making sure I'm doing it Okay, x equals 1/3. It's been a little while since I've written this, so bear with me. So I'm going to go through, I want to say each of those. And that's my groupings. These are my rows. All right, so my client name is going to be from that list of names. And that's going to be X. So it's either going to be the 1, 2, 3, or 4. And then all my so it's going to be rows from starting at my first row up through my second row, or sorry, up through the next place where that occurs. So X plus 1 would give me like this. So the first time through, that would give me the second one. And then I want one less. So I want to start from my first row to my 21st row. I want all of those that are in that. Again, I'm creating a new column. So that 8th column are going to equal my client name. And I do think I want it as a cell. Now, when it comes to be a problem is once I get to this 43, so if X is equal to the number of different clients I have, I can't do the same thing because I can't say from 43 up until the last one. So for here, I'm not going to say this. I'm just going to say, instead of saying a specific number, I'm going to say until the end, which will be the last one. All right, and then let's run it. I might get an error. That's not the error I was expecting to get. So I'm going to see what my data looks like now. So I do have these clients in here. And it started my error at client 4. So from 43, so very simple if statement issue. So if it's that, do that, else do this, because then it tried to do both of them. All right, let's run it again. There we go. So now I've taken that client, that was from the header, and I threw it as something as a column. And then the last thing I want to do is I want to get rid of these rows because that's going to throw off my data. And since I've already identified all those rows here, then I just go in and I say, okay, data, rows, all the columns, delete. Run it. And now if I look at my data, it's cleaned up. So I don't have that title row happening anymore. And I have all of that information stored now in a column. Again, this is the approach I like to take just because it makes it a lot easier to do. Like if I'm string comparing, I can quickly grab all from client 2, client 1, client 3 separately. But if I want to do some summative thing that includes all of those people, I have all of my data here cleaned up and I don't have to deal with those titles. And again, I don't have to manually go in and find all those titles, take forever, delete them out, and that takes way too long. So this is, again, the same format and approach you can do for any data set. Hopefully that answered that question. And yes, I can include that with wherever we want to upload these files.
We thank everybody for coming. And Kelsey, again, thank you so much for this wonderful webinar.